Exercise-associated muscle cramps are common. These involuntary spasms and contractions of muscles that usually occur during or following exercise. Now, for over a century, the leading theory on the cause of these cramps is the electrolyte depletion and dehydration theory, where electrolytes such as sodium and potassium alongside water are lost through sweating. So a traditional remedy, of course, is pickle juice, which in small amounts is claimed to reduce cramps within like 30 seconds. The secret supposedly lies in the high concentrations of sodium or salt in the brine. This was first put to the test back in 2010, using electrical stimulation to induce cramping in the big toe. And then, as quickly as possible, participants drank 1 milliliter per kilogram of body weight of either pickle juice or deionized water. So for a 150-pound person, that would be nearly 70 milliliters or about 4.5 tablespoons. As shown, after nearly 90 seconds, so not as quick as the proposed 30 seconds, but pickle juice was more effective in reducing the duration of cramps than was water, compared to when each group had either no pickle juice or no water, by about 68 seconds. However, the pickle juice did not impact the intensity of the cramp. Interestingly, the amount of electrolytes in the pickle juice could only restore about 2% of what was lost during exercise, thus an unlikely mechanism. So, the authors concluded how pickle juice decreases cramp duration is unknown. This finding was supported in the Pickles intervention, clever, for cramp reduction in cirrhosis patients, since cramps can be one of the strongest independent impacts of health-related quality of life. Participants were instructed to keep pickle juice or tap water on their person for 28 days. If a cramp occurred, they were instructed to record the time, location, and duration of the muscle cramp. Patients were instructed to drink approximately 1 tablespoon of pickle juice or 1 small sip from the squirt bottle at the onset of the cramp. Cramp severity was measured on a 0 to 10 visual analog scale, where 0 means no cramps and 10 means worst cramps imaginable. This scale was measured between water and pickle juice groups when they enrolled in the study and then again at day 28. On average, however, there was large variation from each mean, suggesting wide differences in how individuals respond to the treatments. This is actually a common theme of pickle juice and cramp research. So, with the souring of the electrolyte depletion theory, it is now concluded that in the absence of any effect of the ingested pickle juice on circulating electrolyte concentrations, the mechanism by which pickle juice shortened cramp duration involved activation of receptors in the oropharyngeal region that resulted in reduced firing rate of alpha motor neurons that innervate the affected muscle. In other words, this current theory claims that there are receptors in the mouth, the oropharynx, esophagus, and then in the stomach, called transient receptor potential receptors, that pickle juice, perhaps the vinegar, acetic acid, and or the salt, might activate and in turn trigger a neurological reflex that inhibits the muscle cramp. In theory, then, simply using pickle juice as a mouth rinse should work as well as ingesting it. However, while trending as if the mouth rinse was reducing cramp time, there was not a statistically significant difference in cramp time or discomfort, likely due again to the large variation in individual responses as shown by the standard deviation bars. In the end, the proposed pathogenesis or development of exercise-associated muscle cramps is complex. And based on the current evidence, the effect of pickle juice to reduce exercise-induced muscle cramps is plausible, but with limited effect that varies greatly between individuals.